Hey everybody, today we will do an introduction of sign, magnitude, and binary. Also, we will touch on the two's complement, one's complement and two's complement. And let's say, for example, that you want to identify numbers, right, in binary, right, and you want to identify whether the number is negative or positive. Well, identifying the numbers is not a hard concept, right? Because it's very simple. If you see a 1, if you see something like this, 1 0 0 0 1 1, that is a negative number. That is a negative number. If you see 0 0 0 1 1, that is a positive number, right? This is a negative number. If you see a 1, it's a negative, and you see a 0 on the leftmost digit, it's a positive. But if you see a 1 in the leftmost digit, it's a negative. So, okay, so that is not really hard, right? But what if the number was given on decimal, right? And you want to actually see if the number, whether it's positive or a negative, right? So, for example, if you want to see if the number is, if a number, let's say that you are asked to represent 25 in binary, right? Let's say, for example, unsigned, which is basically a positive number, right? So 25, right? So first of all, how do I get 25, right? So in this case, to get 25, I will have to use probably couple different bits, right? Because it is 25. It is greater than 16, right? So okay, so let's do it. So how will I represent? Well, this number in 20 in a binary. Well, it can, you can actually do the math, right? So you divide it by 2, right? 25 divided by 2 equal to what? It's equal to 12. It's equal to 12.5, right? Divided by 2, 12.5. 12.5, right? So that give me a 1 number, right? Then take this again and say, okay, 12 divided by 2 is equal to 6. That give me a 0, right? Then again, 6 divided by 2 is equal to 3. That give me another 0. Okay? And then 3 divided by 2 is equal to 1.5. They give me a 1. Then 1 divided by just to keep it consistent, 1 divided by 2 is equal to 0.5, right? And then equal to 0.5, right? 1 is equal to 0.5, which is equal to 1. Right? Then so this number, right? Now, do I have another 0? So I stop here, right? So because I cannot go any further because I have a 0 here, right? So basically, this will be considered 25, which if I go like this, up, right? This will go 1, 1, 0, 0, 1, right? So that would be 25 in this case. Right? So now how can you check you got a 25? Well, you do the math again. So this would be 1, this would be 2, 4, 1, 2, 4, 4, 8, 16, right? So here you get 0, right? Because you got zeros in this too. So you got 16 plus 8 plus 1, which is equal to 25. All right, so basically, I mean, I am just doing this again, you know. At this point, if you want to use the calculator to convert that number into a binary, is fine as long as you understand the concept, right? So 1, 1, 0, 0, 1 is 25. Okay. So let's say, for example, that you want to represent this number as a positive. Well, in order to make a positive, you gotta have another 0 in front of it, or maybe 2 zeros. Who cares about the zeros? Right? Let's put another 0 on it. Why not? Now, this is a positive number, right? But if you want to represent that number with another 0, it's also fine, right? The book has another 0 on it. That's also a positive number. Okay, so let's say now, for example, you want to represent this in a sign magnitude that is a negative. Well, all you have to do in this case is make this a 1, will be 1, 0, 0, 1, 1, 0, 0, 1. This will be the negative, the leftmost bit, right? This will be the negative bit. But when I do the math, trying to work this out, it doesn't give it negative 25. It gives me something else. Okay, so how do we solve this problem? The question is, how do we solve this problem? First of all, so this is called sine magnitude. This is called sine magnitude. Because I put a 1 in here. Okay, let's do this quick. Now, to turn this number into a different approach, which is called 1's complement, then it still doesn't give me the right answer. It still doesn't give me the 25. Look, this is 1, right? This is 2, 4, 8, 16, 32, 64, 128. Okay, so these are zeros, and this is the negative. Okay, so let me make this clear. This is negative 128 because this is the 1. Now, if I subtract these numbers from here, so technically here I get 25, right? So I get, in this one I get 16.8 plus 1 is 25. Now, so basically 128 minus 25 is 103. So basically the sign magnitude is only telling me that this is a negative number. It doesn't tell me anything else, right? So now that the sign magnitude doesn't tell me anything. Okay? So now 103, it does not equal negative 25. Negative 103 does not equal negative 25. Okay, so let's say that you want to change this number to what is called 1's complement. In 1's complement, what you do is just change whatever you see a 1, you change it to a 0, and whenever you see a 0, you change it to a 1. So this will become what? Will become, in the 1 complement, will become 0, 1, 1, 0, 0, 1, 1, 0. Now, this is a positive. Oh, actually, let's change the original. I'm sorry. Let's change the original, not the one with the sign magnitude, but the original. Right? Let me make this 0. Okay, so this will be 1, 1, 1, 0, 0, 1, 1, 0. If this is equal to 125, I'm sorry, if this is equal to negative 25, okay, let's try it out. 1, 2, 4, 8, 16, 32, 64, 128, and negative. Okay. Let's do the math and see if this is equal to 125. Well, negative 125 minus, plus 64 plus, because the only negative is this one these are positive, from here to here are positive, plus 32, plus 32, plus 4 plus 2 that gave me negative 23. So this one is also, they gave me just negative 23. So the ones complement also does not give me 25, negative 25. And what I'm looking for, I am looking for negative 25. Okay, so how do we actually overcome this problem? Well, we overcome this problem by, so we know we got a 23 in the ones complement, and I want to just put it right here. I'm pretty sure this is right, 128, so 3264, yeah, 3264 plus 4 plus 2, yep. Okay, so negative 23. Okay, so let's circle that number. Now, so that is the ones complement. The ones complement doesn't give me what I need, right? Okay, so but we still need the ones complement though. Remember that. We still need the ones complement. So now what I'm going to do is do what is called two's complement, right? The two's complement. So the two's complement, the two's complement I'm going to add 1 to this one to get the two's complement, right? So, and that is the two's complement of this one's complement. So this will be two's complement. Right? Okay, so now let me add 1 to this, right? So I add 1. If I add 1, I get what? I get 0 plus 1 is 1. Bring everything down. 1, 1. 0, 0. 1, 1, 1. Now let's see if we get the 1, if we get a negative 25. Okay, so the sign magnitude, sign magnitude give us what? 103. Negative 103. Let's see the two's complement and see what we get by doing the two's complement, right? So what we did was we actually did the one's complement by inverting the bits. In other words, making on or off, vice versa. Now, let's see if we get here the numbers that we need. So, let's do this. So, let me just move this one up a little bit. And let me just put that line right there. Okay, so let's do it. So we got 1. That's a 1. It's going to be 1 because it's, it's the first 1, right? 2, 4, and then we get here, we get 8, we get 32, right? We get 64, we get, actually, wait a second. 1, 2, 4, 8, 32, 64, 64. Wait a second. Let me go back to this. Let me see. Let me see. Let me see here. So they got, yeah, that's the one complement. Yeah, so that's correct. So, but let me just verify this something little quick here. So here we get, so here we get 1, 2, 4, 8, 32, 64, 64, 128. Okay, so how many digits we have? 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so it is correct. So 0, 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so here, let's see, 0, 1, right, that's 1, 2, okay, so 3, 4, okay, I am missing something, that's the error here, okay, this is, here, I went ahead and did something wrong here. I was not really paying attention to too much as what I was doing. Okay, so here is 8. That was correct. But here was 16, right? Here was 32, 64, and negative 128. Right, so basically, let me write this in black. Negative 128. So now this negative 128 is represent this bit, the last bit to the left. Right? So now let's see if we get 25. Okay, so here, let's see, we got 128 plus what? Plus 64 plus 32, right? Plus 4 plus 2 plus 1. Okay? Remember, I'm just adding the numbers, right? The numbers to get to get a decimal value. Let me just make this clear, right? So here, the leftmost digit is negative 128, okay? And this is 64, this is 32, this is 16, this is 8, this is 4, this is 2, this is 1, right? So I am adding all these numbers. I am adding all these numbers, right? This is 8. Right? I am adding all these numbers, right? I am adding all the positive numbers to the negative number. All these positive numbers to this negative number to see if I get negative 25. Okay, so let's do it quick. So here you got 128, negative 128 plus 64 plus 32 plus 7, and here you go. We get here negative 25. Okay, so basically negative 25. Here you go. This is how you represent a number that is given to you in positive, in the decimal value. If the teacher asks you, show me how you represent this number into a negative, into a sign bit, which will give me a negative 25. Step 1, right? Step 1. This is step, you can skip it. Because this sign magnitude doesn't really tell you. It only tells you that you have a negative number, but it doesn't tell you anything now. It doesn't help too much. But these two steps, this and this, are very important. Step 1, you take the ones complement, right? By switching the bits, right? Step 2, add 1 to it. Step 2, add 1 to the value of the ones complement, which becomes 2's complement. And step 3, to prove that you have the right answer, do the math. The leftmost bit is the negative, which is 1 here. Then you do the math and you prove it that is actually a negative 25. That's how you go from a positive number and you show that you can make it a negative 25, or what is also called a sign bit, by doing these 2 steps. First, step 1, 1's complement. Step 2, add 1 to get the 2's complement, and then step 3, you can show that this answer is correct because This is to represent the last bit here to the left, 128. All these numbers, and you add all the positive numbers to negative 128, and you get a negative 25. And this has been what I will do for tonight. I mean, I'm not gonna go over anything else tonight. I hope you like this video. I hope you learned something out of it. If you like this video, just subscribe and just give me a like. Thank you for watching.